Welcome to Stickman Physics. Today, we're exploring exactly what a human would see if they could run at 99% the speed of light. You hit the button and accelerate instantly, moving from a standstill to an extreme velocity down a straight, gridded hallway. Human biology evolved to process light hitting our eyes at a specific pace. But what happens to your vision when you move fast enough to catch up to the light itself? In a normal sprint, the edges of your vision might appear slightly blurred. At near light speed, the very geometry of the hallway begins to change. This velocity overrides the standard rules of motion, altering how we perceive the space and light around us. As you reach your absolute top speed, look closely at the grid lines on the walls and the floor. You are experiencing relativistic aberration of light. This occurs because your extreme forward motion changes the angle at which photons reach your eyes. Here, straight lines perpendicular to your path bend backward into curved hyperbolae. Your field of view expands, pulling more environment into your forward sight. This creates a paradox. Objects directly in front of you scale down and move further away. It creates the sensation of running at full speed, while the world ahead recedes into a distant point. The straight hallway has been visually reshaped into a curved, receding funnel. Beyond the geometry of the walls, consider the color of the light directly in your path. This is the relativistic Doppler effect, caused by your velocity relative to the incoming light waves. As you move toward the source, you collide with light waves more frequently, physically compressing the waves reaching your eyes. This compression shifts the light across the visible spectrum, from low-frequency red through green, and eventually into a brilliant blue. If you run fast enough towards a red stoplight, your extreme speed actually squishes the incoming light waves together. At this extreme speed, every familiar color in your path shifts toward the high-frequency blue end. Your momentum determines the observed frequency, turning the entire view ahead into a high-energy blue landscape. While the colors shift, the volume of light entering your eyes is also increasing. This brings us to the final stage of relativistic vision, the searchlight effect. The aberration we discussed earlier funnels light rays from all surrounding directions into a single forward-facing point. The result is a blinding intensity. The world directly ahead washes out, as if you were looking directly into a high-powered spotlight. The brightness becomes physically overwhelming, forcing you to cover your eyes and skid to a stop. Though the laws of physics allow for these speeds, human vision is incompatible with the warped, high-intensity reality of relativistic motion. If you ever find a way to move this fast, do not forget your sunglasses.